Okay. So this is the next concept, solving the circuits with the help of equipotential points. First of all, what is meant by equipotential point? Equipotential points means what? So the points which are at same potential. Okay, ma? The points which are present at same potential, they are called as equipotential points. So same concept we have studied in capacitances also, in capacitors concept also, we have solved the problems with the help of equipotential points. Clear? So here also we are using the same technique of solving the problems with the help of equipotential points. Okay, let us see. See, for example, if I have a circuit like this, okay, so if I have a circuit like this, clear? So let it be 4 ohms and let it be 3 ohms, okay, ma? Then I can call this one to be 2 ohms and let it be 3 ohms, okay? Now if I take this point A and if I take this point to be point B, so point A and B, are the equipotential points or not? Points A and B, definitely they are equipotential points. What is the reason? Because whatever potential I have supplied here, some potential will be dropped in this branch. Okay, so what is the equivalent resistance of this branch? 4 into 3 divided by 4 plus 3. So according to that resistance, some potential will be dropped out of this total supplied potential, and remaining potential will appear here. Okay, ma? So let total potential drop in this branch is V dash. Okay, then what is the potential existing at point A? Potential at point A will be V minus V dash. Correct or not? Correct only, no, ma? So in this total branch, potential drop will be V dash. What is meant by potential? Already we have studied, no, ma? Potential is nothing but work done per unit charge. Clear? So to make a unit charge travel throughout this circuit, how much amount of work I have to do? That is nothing but potential. So out of the total work which I am doing, some of the work is taken, or some of the energy is taken by this circuit, a combination of 4 and 3. Okay. So in this one, if potential drop is V dash, potential at point A will be V minus V dash. Next, what will be potential at point B, ma? What will be the potential at point B? Come on. Potential at point B will be, here also it will be V minus V dash only. How can you say it is V minus V dash only, ma? Potential at point B also V minus V dash only. How can you say this one? How can I say this one is that between A and current is flowing. Current is definitely flowing between A and B. If current doesn't flow, how can current flow in 2 ohms and 3 ohms resistors? Current is definitely flowing. Then how? Yes. So in between A and B, there is no consumer of voltage. Okay, ma? There is no component which consumes voltage, which requires energy for charge to flow through that component. For example, if I have a resistor, if current is flowing, somebody should push this charge so that current enters into this one. So therefore, to charge flow through this resistor, definitely we have to do some work. But in traveling from A to B, there is no such opposition. There is no such resistance. So therefore, potential drop will not happen in between A and B. So A and B, I can call them to be as equipotential points. Okay, ma? So such points we call them as equipotential points. So what is the point here we have to write? Here, current is flowing. Current is flowing. What is meant by current is flowing? I is not equal to 0. Okay, ma? Current is not equal to 0. It means current is definitely flowing in between A and B. But what is happening? But resistance is 0. But resistance R is equal to 0. If resistance is equal to 0, then what will be the potential drop? A potential drop is equals to V into I into R. No, ma? V is equals to I into R. Current is not 0, but resistance is 0. So therefore, total potential drop also will be equal to 0. So that is the reason why there is no potential drop between A and B. So and A and B, I can call them to be equipotential points. Are you able to understand, ma? So in this method, I can write. Okay, so therefore, how can I redraw this diagram? So first of all, you calculate the equivalent resistance of this one, ma? Equivalent resistance of this one is how much? 4 into 3. 4 into 3 divided by 4 plus 3. How much it is? So 4 into 3, 12 divided by 7. Clear, nama? Calculate equivalent resistance of this one. 2 into 3 divided by 2 plus 3. 2 into 3 divided by 2 plus 3. So 6 divided by 5. Clear, nama? Now, to this total resistance of 12 by 7 and this resistance of 6 by 5, they are connected in series connection. So therefore, what is the total equivalent resistance? Total equivalent resistance is 12 by 7 plus 6 by 5. That's all, nama? Because they are connected in series connection. So if you take the equivalent resistance, 7 5s are how much? 7 5s are 35. That will be the LCM. So 5, 12 5s are 60 and 5, 7. So 7 6 are how much, ma? 42. So total how much it is? 102 divided by 35. Clear, ma? This will be the total equivalent resistance of this circuit. Are you able to verify? Clear, na, ma? Now, how can I draw the same circuit? 102 divided. Okay, no problem. Let it be up to here only, no problem. This circuit, if I have simplified this one, then equivalent resistance I got to be 102 divided by 35. Clear, ma? Now what I can do is, see, ma, two equipotential points, if I join them, will anything happen? Two equipotential points, if I join them, will anything happen or not? Can you say anybody? Nothing is going to happen. So same circuit, what I can do, same circuit, I can draw like this also. So this is 4 ohms and this is 3 ohms. Clear, no, ma? And now I will join both of these points A and B, then my circuit will become like this. So this is 2 ohms and this is 3 ohms. Clear, no, ma? So this will be my total equivalent circuit. Okay. Now can you say what is the difference between this circuit and this circuit, ma? So what is the difference between both the circuits here? So no difference. Here we have separated both points A and B like this. Clear, no, ma? And we have joined both equipotential points A and B, and this is the circuit which I got. So here also equivalent resistance becomes 102 divided by 35. Here also equivalent resistance remains to be 102 divided by 35. So that is the advantage of equipotential points. Are you able to understand, ma? Equipotential points, you can either separate them or you can combine them. So make a note of that point. Clear, no, ma? So here what we can write, is equipotential points, okay, so can be separated or joined as needed to simplify the circuit. Okay, ma? So according to our requirement, either you can separate them or either you can combine them to simplify the circuit. That is the meaning of this. Clear, na, ma? Okay. So for example, if resistors are arranged like this, so this is one resistor, this is another resistor. Clear, no, ma? Next, this is one more resistor and this is another resistor. Clear, no, ma? So this is resistance A, B, C and D. Clear, no, ma? So current, if it is flowing like this, clear, no, ma? Then current is entering into these branches. So this is point X and this is point Y. So can I say X and Y, they are at same potential, ma? X and Y, definitely they are at same potential, no? So what I can do, instead of placing them separately, I can write them as a simple circuit like this. So I can write this is one resistor and this is another resistor. Clear, no, ma? Then I can write this one to be one resistor and this one is another resistor like this. So this is A and this is D. Similarly, this is B and this is C. So just I have joined X and Y. So both X and Y are present at same position, X comma Y. So I can simplify this circuit like this also. Okay, ma? So this is the method of solving the problems with the help of equipotential points. Okay, ma? One method. Okay. So let us see one more method of solving this one, ma? See, for example, if I draw a circuit. See, in this condition, what is happening? What is this case? Here the case is a current is definitely flowing in this branch. Current is flowing, Nama. If this is I1 current and if this is I2 current, what is the total current here? Total current is I1 plus I2. So current is definitely flowing, but still potential drop is 0. Why potential drop is 0? Because there is no resistance in this circuit. All of you are able to understand? So what is this case number 1? Case number 1 is current is definitely flowing. Current is not equal to 0. Resistance is 0. So therefore potential difference is also 0. Now let us study about another condition. Another condition is, for example, if I draw a circuit like this, case number 2. Now I am writing example for case number 2. What is case number 2? Let us see. Clear, ma? So this is one resistor. Clear, ma? So this is another resistor and this is another resistor. So battery is connected like this. Clear, ma? So this is a 2 ohms, this is a 3 ohms, this is a 10 ohms, and total potential supplied is 30 volts. Clear, ma? Now can you say what is the current flowing in 2 ohms resistor? What is the current flowing in 3 ohms resistor? And what is the current flowing in 10 ohms resistor? And what is the current flowing in this branch? Can you say? Similarly, what is the potential drops across 2 ohms, 3 ohms and 10 ohms? All these values you are supposed to calculate. Anybody, ma? Already we have studied these kind of problems in capacitances. Can you say anybody? Same. Current does not flow through 10 ohms, correct. What is the reason? What is the reason? Yes, current always chooses the path in which there is no resistance. Clear, Nama? Sima, here current will be produced by this in this circuit and current reaches up to here. Then it will see 2 branches. So this is one branch where resistance is present. This is another branch where there is no resistance. Clear, ma? So here if I amount of current is produced, so total current will flow into the same branch and total current will flow into 3 ohms resistor like this. Clear, Nama? So therefore what is happening to this 10 ohms resistor? There is absolutely no use of this 10 ohms resistor. Are you able to understand, ma? So what is this method called as? This is called as short circuiting. Okay, ma? So here what we are doing? We are short circuiting. We are short circuiting 10 ohms resistor. Okay, ma? We are short circuiting 10 ohms resistor. So therefore what current will do? Current will choose low resistance path. Current will choose low resistance path. Low resistance, or you can call it as current will choose zero resistance path, current is going to choose. So therefore absolutely there is no use of this resistor. Okay, ma? So is current flowing through 10 ohms resistor, ma? Current, is it flowing through 10 ohms resistance? No, current is not at all flowing through 10 ohms resistance. Okay. If current is not at all flowing, resistance, is it 0? Resistance is not 0 here. But what is the potential drop in 10 ohms resistance? Potential drop formula I into R only, no, ma? Current flowing is 0, but resistance is not 0, but definitely potential drop in 10 ohms resistance is 0. Are you able to understand, ma? So therefore there is no current which is flowing in 10 ohms resistor. So if I take this point as a point A and if I take this point as a point B, now what I can say? I can say potential at point A is equal to potential at point B. This reasoning I can give, Nama, definitely. Correct or not? Come on. Okay. So if potential at point A is VA, if potential at point B is VB, can I say VA is equal to VB or not? Can I say VA is equal to VB or not? Definitely I can say. Clear, Nama? Why I can say? Because total current after entering up to here, now there is no drop of potential, there is no resistance. Why? Because current is not at all entering into 10 ohms resistor. So what is the difference between case number 1 and case number 2, ma? In case number 1, through equipotential points, current is flowing. Are you able to understand the difference, all of you? In case number 1, current through equipotential points is flowing, but resistance is 0. So therefore there is no potential drop. In second condition, what is happening? In second condition, current is not flowing through the resistor, but resistance is not 0. Clear, Nama? Current is 0, resistance is not 0. But still potential difference is the product of I into R. So potential difference will become 0. So definitely I can say these points of A and B, which are connected to 10 ohms resistor, they are connected at same potential. So have you understood the difference in both of them, all of you? All of you, have you understood? See, this is one circuit we have drawn. This is another circuit we have, same circuit. So this is point A and this is point B. So these 2 points are also equipotential points, no? But here is current not flowing. Current is definitely flowing. But why potential drop is 0? Because resistance is 0. Clear, Nama? In second condition, if you take this point and this point, current is not at all flowing through this branch, through this 10 ohms resistor. So therefore here, current is 0, resistance is not 0, but still potential difference is 0. Okay. So therefore this circuit, how I can redraw? This circuit, I can redraw like this, Nama. So what I can do now is, see what we are doing here. Okay, ma, first make a note up to here, then I will write the reasoning here. Potential at point A is equal to potential at point B. Therefore, join A and B. If I join A and B, will anything happen, ma? If I join points A and B, is anything going to happen? Come on, you should answer, all of you. No, nothing is going to happen because both points are present at same potential. So therefore, this circuit I will draw like this. Clear, ma? So this is my terminal A comma B. So if I join them, then what happened to 10 ohms resistor? 10 ohms resistor, now it is present in a loop here. 10 ohms resistor is present in a loop. This is 10 ohms resistor. Clear, ma? Then what happened to 2 ohms resistor? So this is 2 ohms resistor. Clear, ma? And this one is 3 ohms resistor. So 2 ohms and 3 ohms. Clear, ma? So this is the potential difference of 30 volts which we are supplying. Okay, ma? So A and B points I have joined like this. Okay. So can I draw like this or not, ma? Is there any problem in this one? Points A and B, I have combined them and joined like this. Is there any problem? Can I draw? Definitely we can draw. Clear, Nama? Because A and B are equipotential points, definitely I can draw. Therefore, what happened is here, the side effect is that 10 ohms resistor is present in a loop. 10 ohms resistor is present in a loop. And wherever resistances are present in a loop without a battery, current cannot flow through them. This is another conclusion which we are writing. Clear, Nama? So write down these points here. So what is the point which I have to write here? So by connecting A and B, 10 ohms resistor entered into a loop without battery. Okay, ma? Entered into a loop without battery. Clear, na, ma? So therefore, if loops are formed without batteries or without cells, clear, ma? Then what will happen? Then current does not enter the loops. That is the meaning of this one. Clear, na, ma? So wherever if I join equipotential points, if loops are formed, then what can I say about the loops? And in loops, batteries should be absent. So in these loops, if batteries are absent, then current cannot enter into these loops. Clear, na, ma? So this is one point which we can understand. So if a current cannot enter into these loops, is there any use of this 10 ohms resistor, ma? Is there any use of this 10 ohms resistor? There is no use of this 10 ohms resistor. So I can remove this 10 ohms resistor. Clear, ma? So this is the new circuit which is formed. So 2 plus 3, they are connected in series connection. So 5 ohms is the total equivalent resistance. So this is our discussion on equipotential points. So have you understood, all of you? All the students, it is clear now? So make a note up to here. Then we will do some problems on these equipotential points in the next class. Okay, ma? So this is one important conclusion which we got. So wherever loops are formed, so you can remove this loop. Now I will give you one question. Try to answer that one. Okay. See. So find equivalent resistance between A and B. Can you say the answer of this? Find equivalent resistance between A and B. Can you say, ma? So A and B means what? These two terminals are connected by a battery. That is the meaning of this one, no, ma? A and B are connected to the terminals of a battery. So current is produced here. So let I amount of current is produced. Okay. So this I current, after reaching up to here, now it is seeing two branches. So 4 ohms and 4 ohms and this branch. Now current, will it enter into both branches or current will enter into only one branch? Huh? 2.3 is wrong. Other students? See, my current after reaching up to this point, it is seeing two branches, 4, 4 and this branch. Current, how it gets divided? Can you see? No, that is wrong. See, ma, here, current will not enter into this branch at all. What is the reason? What is the reason? Reason is that because this is a short circuited path, no, ma? So if I name this points as C and D, CD is a short circuit. CD is a short circuit. Clear, ma? So current will not enter into this branch. So current directly enters into this branch and it reaches a terminal B. Then again it enters into the battery. That is what is going to happen. Clear, ma? So therefore, directly how can I write the diagram of this one? I can draw like this. So this is one resistor. Clear, ma? Then this is another resistor. So this is a 2 ohms and this is a 3 ohms. This is a point A and this is a point B. So 2 plus 3. So our equivalent resistance is 2 plus 3 is equals to 5 ohms. That is my answer. Clear, nama? So wherever the current sees a short circuited path, a path with no resistance, then current tries to enter into this branch, bypassing the other branch. Are you able to understand, ma? Or you can also call it as point C and point D, they will behave like equipotential points. So C and D behave like equipotential points. Okay, ma? So why they are behaving like equipotential points, ma? They are definitely equipotential points. What is the reason? Reason is that there is no resistance in between them. There is no resistance in between them. So definitely they are behaving like equipotential points. So again, how can I redraw this circuit in second manner? So this is one resistor. Clear, no, ma? And this is another resistor. So this is a terminal A and this is a terminal B. So this is a 2 ohms and this is a 3 ohms. Then what about 4 and 4? 4 and 4, they enter into a loop like this. So this is a 4 ohms resistor and this is also 4 ohms resistor. And these points are point C and point D. Okay, ma? So point C and point D, they are equipotential points, no, ma? So we are joining them. So if I join C and D, then this 4 ohms and 4 ohms, they enter into a loop, no? They enter into a loop. Then what is the property of loop we have studied previously? What is the property of loop we have if a loop is present without a battery, then current cannot be present in that battery, in that loop. Clear, nama? So there is no use of this 4 ohms and 4 ohms. I can remove this 4 ohms and 4 ohms resistors. And this is the circuit which I get. So 2 plus 3 is 5 ohms is the equivalent resistance. Okay, ma? So calculate these two values, ma? So here we have terminal A and here we have terminal B. So we are supposed to calculate equivalent resistance between A and B. And this is another circuit. Okay, ma? So first of all, can you say how can I solve this one? What is the equivalent resistance between A and B? Can you say? Equivalent resistance between A and B. Anybody? Any idea, ma? See, ma, here, first resistor, second one, third one, and fourth one. One end of all these resistors, they are present at a potential of A. Correct only, no, ma? So if I call this resistance R1, R2, R3, and R4, so one end of all these resistors, they are present at the same potential of potential A. Now if you take remaining ends, other ends, then this is the other end of first resistor, other end of second resistor, other end of third resistor, and another end of fourth resistor. So all of them, can I say they are present at the same potential, ma? Okay. So if I name this as C, D, E, and F, can I say potential at C is equals to potential at F is equals to potential E is equals to potential at D is equal to potential at D, potential at B. Can I say, ma? Can I say or not? Definitely I can say, because in between all these points absolutely there is no resistance. Clear, no, ma? It means definitely all these points, they are present at same potential. So it means that all the one end of all the resistors are at a potential of A, and other end of all the resistors, it is present at a potential of B. So therefore, how these resistors are connected, ma? Are they connected in series connection, or are they connected in parallel connection? What kind of connection are they? Definitely they are in parallel connection. So therefore, how can I draw this circuit? So this is one resistor, second one, third one, and fourth one. That's all, no? So this is a terminal A and this is a terminal B. So this is a 4 ohms, this is a 4 ohms, this is a 4 ohms, and this is a 4 ohms. Clear, no? So therefore R equivalent is how much? 4 by 4. 4 by 4 is the 1 ohm is the equivalent resistance of this side. That's all. That is my answer. Similarly, what about this one? What about this one, ma? How can I say? So this is my terminal A, this is my terminal B. Okay. Now what about equivalent resistance of this circuit? Eight ohms. 8 ohms. I don't think it is 8 ohms, ma. I don't think. 5. 5 also I don't think. How? See, again go with the same concept. See, this is terminal A. First draw this terminal and we have one resistor. So this is a terminal A. I am reaching up to this point. Clear, Nama? So let this point be point C. Okay. So from point C we have one resistor, second resistor, and third resistor. So from point C we have one resistor, second resistor, and third resistor. Clear, Nama? Now other ends of all these resistors, can I say all of them they are at same potential, ma? So if I take point D, this is a point E, and this is point B. Can I say potential of point D is equals to potential of point E is equals to potential of point B? Can I write like this or not? And definitely I can write like this. It means that all these they are present at the same potential, and this is point B. Clear, Nama? So this is point B, this is point E, and this is point D also. Because 1, 2, 3, all these 3 points they are present at same potential. That's all. Clear, Nama? What is this one? 4 ohms. This is also 4 ohms. This is also 4 ohms. And this is also 4 ohms. Clear? So 3 equal resistors, they are connected in parallel connection. So equivalent, how I can draw? So this is a 4 ohms. This is a 4 by 3. Clear, Nama? So this is terminal A and this is terminal B. Now again these two they are connected in series connection. So 4 plus a 4 by 3, solve this one. That should be our answer. LCM is 3. So 12 plus a 4. So 16 divided by 3 ohms. That is the equivalent resistance. That's all. So have you understood, ma? So with the help of equipotential points, very easily we can solve the problems. So be careful about this one. Okay, you can answer this one. Anybody, ma? Current is not flowing in any one of the branches, ma. Why? How can you? Resistors are lesser. No. Same. Which one, ma? Which resistors are in parallel connection? 12 12, 24. Next 12, 24 and are you not able to see this one? This is 8 ohms. 12, 24, 8 and 6. Very good. How can you say they are in parallel connection? How can you say they are in parallel connection, ma? How can you say they are in parallel connection? See, ma. Yes. 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 That's all. Clear now, ma? So, no, they are not connected to A and B. Let us see. So, let us consider this is a terminal C. Clear now, ma? And this is a terminal D. So, this is a terminal E. Clear, ma? And same is this is terminal B. If this is B, this is also B only. Okay, ma? Now, here, point C and D. Is there any resistance in between this one? Okay, ma? Point C and D, there is no resistance. So, definitely I can say point C and D, they are present at same potential. So, VC is equal to VD because they are present, they are short circuited here. Clear, nama? So, therefore, what I can say, this resistor and this resistor, one end of this resistor, one end of this resistor, one end of this resistor, all of them they are connected at same potential. Clear, nama? So, therefore, how can I redraw this circuit? Let us see. So, this is point A. So, this is my 6 ohms resistor. Clear, nama? From here, I will reach to point C. I will reach to this point. Clear, nama? So, from here, there is one resistor, there is second resistor, and there is a third resistor. So, 1, 2, and 3. Okay, ma? Now, all the remaining ends. So, this is the second end of this first resistor. Similarly, to this resistor, this is the second end. So, this resistor and this resistor, they are connected at same potential. Clear, nama? Similarly, if you see this resistor, other end is meeting at a point B. And E and B, they are short circuited. So, therefore, what I can say, potential of point E is equals to potential of point B. I can write like this. Clear, nama? So, remaining end of all these resistors, they are present at a potential of E and B. Clear, nama? So, this is my terminal B, or you can call it as a terminal E also. This is my equivalent circuit. Okay, ma? So, therefore, here what is happening, this is a 6 ohms resistor, this is a 8 ohms resistor, this is a 12 ohms resistor, and this is 24 ohms resistor. Now, calculate the equivalent resistance of them. So, these three resistors, they are connected in a parallel connection number. So, 1 by 24 plus 1 by 12 plus 1 by 8. Clear? So, if you take the LCM, it is a 24, 1 plus a 2 plus a 3. So, 1 by R is equal to. So, therefore, what is R value? R value is equals to 24 divided by 6. So, it is 4 ohms. Clear, ma? So, this total is 4 ohms. 4 ohms is connected to 6 ohms resistor. So, therefore, this is 6 ohms and this one is 4 ohms. Clear, ma? So, this is terminal A and this is terminal B. So, total equivalent resistance 6 plus 4 is 10 ohms. This is my equivalent resistance of A and B. That's all. So, have you understood, ma, all of you? So, all of you, I hope you have understood. So, I will give this is 10, this is 20, ma, and this is 20, this is 10. Clear, ma? And these two branches, they are not touching with each other. One is crossing. This symbol indicates that this branch and this branch, they are not touching with each other. Okay? Come on. How can I do this calculation? Sima, if this is point A, can I call this one also as point A? Because there is no resistance in between these 2 points. If this is A, is this is also A, this is also A only, no? That's all, Rama. Because again, from here to here, there is no resistance. From here to here, there is no resistance. Okay? 1 minute, ma. I too don't know. Let us see. Sima. Sima, if this is point B, this is also point B and this is also point B only, no, ma? Clear? So, I am supposed to calculate equivalent resistance between A and B. So, let us see how we can redraw this circuit. Clear, no, ma? So, first starting from point A, clear, no, ma? So this is one branch directly going to point B. So this is terminal A, this is terminal B. So in between A and B, how many resistors are present? One resistor is present here. So I will write that resistance. So this is point B. So this is 60 ohms resistor. Are you able to understand? Now if I see the top branch, okay, let us, I too don't know. So from A to B, again there is one more resistor which is again equal to 60 ohms. So therefore this is one more resistor whose magnitude is again equal to 60 ohms. Clear now? Now if I see from here A to B, there are two resistors, 10 ohms and 20 ohms. So therefore, so this is a combination of two resistors, 10 ohms and 20 ohms traveling from A to B. Similarly, if I see from here A to B, again there are two resistors, 20 ohms and 10 ohms. So therefore again I can redraw this circuit. So this is a 20 ohms and this is a 10 ohms. So this is my total equivalent circuit. Okay. Now simplify this circuit. So therefore this is 30 and this is also 30. 30 and 30 they are present in parallel connection. So total it is 15. Okay ma. So 60 and 60 they are also connected in parallel connection. So it is 30. So 30 and 15 they are present in parallel connection. So equivalent resistance finally is 15 ohms and this equivalent resistance is 30 ohms. Clear nama? So this is a terminal A and this is a terminal B. So 15 and 13 again they are connected in parallel connection. So 30 into 15 divided by 30 plus 15. Okay ma? So 30 into 15 divided by 45. 15 ones are 53 is 10 ohms is the equivalent resistance. Clear ma? So 10 ohms is correct. That is our answer. Understood nama? So this branch and this branch they are in parallel nama. So 30 and 30. So 30 by 2 is 15. 60 and 60. 60 by 2 is 30. 3 ohms resistor. A to B 6 ohms resistor. So therefore this is one resistor. Clear nama? This is 3 ohms resistor. And from here we have one more resistor which is called as 6 ohms resistor, this one. Clear nama? And from A to here we have one connection here. Connection is present. So therefore how can I draw this one? So 2 ohms resistor nama. So 2 ohms resistor connected like this. And this is 8 ohms resistor which is connected like this. So 2 ohms and 8 ohms. So here we have a connection. Next from here we have 6 ohms resistor. And from here we have 4 ohms resistor going to point B. So this is a 4 ohms resistor. So this is the given circuit. Okay ma? Now can't you simplify this one? Now maybe, I too don't know. So let us see ma. So this 2 ohms and 8 ohms, they are connected in parallel connection. Similarly, 6 ohms and 4 ohms, they are connected in parallel connection. Now to this both branch, 3 ohms and 6 ohms also, they are connected in parallel connection. So first to do this calculation, 2 into 8 divided by 2 plus 8. So 2 into 8 divided by 10. So 2 ones are 2 fives are 8 by 5. Clear ma? Next you do this calculation, 6 into 4 divided by 6 plus 4. So 6 into 4 divided by 10. So 2 2s are 2 5s are. So 12 by 5. Clear nama? So 8 by 5 and 12 by 5 they are connected in series connection. So 8 by 5 plus 12 divided by 5. So 20 divided by 5 is 4 ohms. That is the equivalent resistance of this branch. Clear nama? So therefore, if I redraw this circuit, this is 3 ohms resistor, this total is equal to 4 ohms resistor, and this is a 6 ohms resistor. All of them they are connected to terminal B. Clear ma? So now 3, 4 and 6 they are connected in parallel connection. So 1 by 3 plus 1 by 4 plus 1 by 6. So LCM I can take 12 no? 12 I can take LCM. So 4 plus 3 plus 2. So this is equals to 1 by R equivalent. So therefore R equivalent is how much? Okay, let us see. So 12 divided by 9. 12 divided by 9 is how much ma? 3 3s are 3 4s are. So 4 by 3. 4 by 3 is how much? It is 1.33 ohms. That is the equivalent resistance. Okay ma? So 1.33 ohms is the equivalent resistance of this circuit. That's all. All of you got the same answer ma? If this is point A, what is this point ma? Can I call this one also as point A? Can I call or not? If this is my point A, this is also point A only, no? Correct or not? 12 ohms, 12 ohms, 12 ohms. 12 ohms is not correct. Okay ma? See ma, if this is point A, this is also point A and this is also point A, no ma? Clear? Similarly, if this is a point B, this is also point B and this is also point B. Okay. So I am supposed to calculate equivalent resistance between A and B only. So in between A and B, first of all, there is one resistor which is called 8 ohms. First draw that circuit. Clear ma? So between A and B, clear ma? So there is one resistor which is called as 8 ohms. Huh? How much ma? Answer? 4 ohms is correct. 4 ohms is correct ma. Clear ma? Okay. So in between A and B there is one 8 ohms resistor. Are you able to understand? Okay. Next from terminal A there is one resistor of 6 ohms and so from the same terminal there is one more resistor which is called as 12 ohms. Clear na ma? It means this is 6 ohms and 12 ohms, they are in series connection or are they in parallel connection ma? Okay. So this 6 ohms and this 12 ohms, they both start from point A only. So definitely 6 ohms and 12 ohms they are connected in parallel connection. So therefore, and both of them they are ending at this point. So let us call this point as point C. Okay ma? So therefore what I can do, so one is 6 ohms resistor and another one is 12 ohms resistor. So both of them they are ending at point C. This is my point C. Okay ma? Now from point C I reach up to point D. Okay ma? And C and D definitely they must be at the same potential. C and D must be at the same potential because there is no resistance in between them. Clear now? Now if you see from D I will reach to point B, one resistor. From same D I will reach to again point B, again there is one more resistor. So 12 ohms and 6 ohms they start from point B, they end on point D and they end on point B. Starting is from point D, ending is on point B. It means that if I take this point to be my point D, clear na ma? So in reaching up to B we have two resistors again. Clear ma? So what are the three resistors? One is a 6 ohms resistor, another one is 12 ohms resistor. So this is my equivalent diagram. Okay. Now very easily we can calculate nama. So what is this? This is 6, this is 12. So these two they are connected in parallel connection. So 6 into 12 divided by 6 plus 12. So 6 into 12 divided by 18. So 6 1s are 6 3s are 4 ohms is the equivalent resistance. Now here also 4 ohms is the equivalent resistance. So this 4 ohms and this 4 ohms they are connected in series connection. So my equivalent resistance is like this. This is 4 ohms. This is also 4 ohms and this is my 8 ohms resistor. So this is a terminal A and this is a terminal B. So 4 and 4 they are connected in series, total 8 ohms, 8 and 8 they are connected in parallel connection. So therefore total equivalent resistance is 4 ohms. That is my answer. Okay. So have you understood how we are solving the problems by using equipotential points? All of you? That's all. Clear now? Ma? That's all. Make a note of this one. Okay, ma? So, some more concepts we will study in the next class. Okay. So, whenever a circuit is given, you should check for all the conditions, ma. First of all, you should check for equipotential points. Then you should check for symmetry also. Okay. If there is no symmetry, if there is no equipotential points, then you should go for other methods of solving the problem by using star delta transformation. They are also present, which we will study in the upcoming classes. Okay, ma? We are supposed to calculate equivalent resistance between A and B. Okay. So can you say, how can I calculate this one? By using the concept of equipotential points. Anybody? Okay, ma? So first let us search for equipotential points, ma. So this is point A and here if potential is VA, definitely here also potential will be VA and here also potential will be VA only. That's all, ma. So these 3 points, all of them they are present at same potential. Okay. So from this, so if this is point A, this is also point A and this is also point A. Okay, ma. So from A to B, I have one resistor. Okay. First let us draw that resistor. So this is point A and let this be point B. Okay, ma. So from A to B, I have a 3 ohms resistor. Okay, ma? So this is a 3 ohms resistor which is present in between points A and B. This is the first resistor. Okay. So next, if I see here, so A and this is also point A. So from here I have 6 ohms resistor, from here I have another 6 ohms resistor. Clear? So consider they are meeting at point C. Okay, ma? So 6 ohms and 6 ohms, they are meeting at point C. Now can you say this is 6 ohms and this 6 ohms, are they in series connection or are they in parallel connection, ma? So this 6 ohms and this 6 ohms, both of them, they are starting from point A only. Clear, ma? So this 6 ohms and this 6 ohms, are they connected in series connection or are they connected in parallel connection? What kind of connection they are? Definitely they are in parallel connection, no? So therefore, how can I draw a diagram of them? So I can draw. So this is one 6 ohms resistor. So this is another 6 ohms resistor, and both of them, they meet somewhere at point C. Okay, ma? Now from point C, in reaching up to point B, I have two resistors. So from C, there is one 6 ohms resistor and also there is one 2 ohms resistor. So therefore, how can I draw a diagram of this one? So this is 6 ohms resistor and this is a 2 ohms resistor. Finally, they meet at point B. Clear, ma? So this is 6 ohms and this one is 2 ohms resistor. Clear? Now can't I simplify this circuit, ma? Now it is very easy to simplify this one, no? So this is 6 and 6. So finally, my circuit will be like this. So 6 and 6, they are connected in a parallel connection. So equivalent resistance will be equal to 3 ohms. So this is 3, this is 6, and this one is 2. Okay, ma? Then we have reached to point B from point A. And from A to B, there is one more resistor which is called as 3 ohms resistor. Okay. So therefore, 3 ohms, 6 ohms and 2 ohms, they are connected in series connection. To this combination, this 3 ohms is in again in parallel combination. So 9 plus 2, 11. Clear, ma? So 11 ohms, this one is 3 ohms. Okay. So this is a terminal A and this one is a terminal B. So 11 ohms and 2 ohms, they are connected in parallel combination. So therefore, R equivalent is equals to 11 into 3 divided by 11 plus 3. So 11 into 3 divided by 14. So 33 divided by 14 ohms will be the total equivalent resistance of this circuit. So this is the given circuit. We are supposed to calculate equivalent resistance between again points A and B. Okay, ma? So let us see how we can do this calculation. So from point A, there are two resistors. This is one resistor and this is another resistor. So let us name this terminal as terminal C. If this is C, can I say this one is also C, ma? Can I say or not? If this is a terminal C, this one also is a terminal C only, no? Because both of them, they are present at same potential. It means that from A, we are reaching to C with the help of 3 ohms resistor. Similarly, we are reaching C to 6 ohms resistor also. It means this 3 ohms and this 3R and 6R, are they connected in series or are they connected in parallel? Come on. This is terminal A. I am reaching up to terminal C. So in reaching up to terminal C, how many resistors are there? One resistor of 3R, there is another resistor of 6R. Okay, ma? So I have reached up to here. So definitely 3R and 6R, they are connected in parallel connection. Okay. So next from same C, I am reaching to point B, and from same C, I am reaching to point B with the help of two resistors. One is a 12 ohms resistor, another one is 6R resistor. So therefore, same circuit how I can draw from same terminal C. So I am reaching up to point B with the help of one 12 ohm resistor, and again to point B with the help of one 6R resistor. That's all. This is my total equivalent circuit. That's all, number. So if I simplify this one, so these two, they are connected in parallel connection. So 3 into 6 by 3 plus 6. So 3 into 6 divided by 9. So 3 1s are 3 3s are 2 ohms is the equivalent resistance. Clear? Similarly, 12R and 6R, they are connected in again parallel connection. So 12 into 6 divided by 12 plus 6. So 12 into 6 divided by 18. 6 1s are 6 3s are. So 3 4s are 4 ohms is the equivalent resistance. Clear? So therefore, total equivalent is how much, ma? So this is 2 ohms. And this one is 4 ohms. This is the terminal B. So total equivalent resistance between A and B is equals to 6 ohms. That is our answer. Okay, ma? So this is the arrangement of resistors. So you are supposed to find out equivalent resistance between A and B. See how you can do this calculation, ma? So first of all, I will search for equipotential points. I will see how many equipotential points are present. So this is, here if potential is VA, this is also point A, this is also point A, and this is also point E. Clear, ma? Similarly, if this is B, this is also B, this is also B, and this is also terminal B. Okay. So in between A and B, first of all, I have 4 resistors, 1, 2, 3, 4. 4 12 ohms resistors are present. Okay. So first I will draw that circuit, ma. So this is a terminal A, and let us suppose this is our terminal B. Okay. So from A to B, there are 4 12 ohms resistors. So this is one resistor, this is another resistor, this is another resistor, and finally this one is another resistor. Clear, ma? So 12 ohms, 12 ohms, 12 ohms, and 12 ohms resistors. So 4 12 ohms resistors are present. Okay. So then if I reach from here, then from here to here in reaching point B, I have 2 resistors, 6 ohms and 24 ohms resistors. So first of all, I will draw them. So one is 6 ohms resistor, another one is 24 ohms resistor, and both of them they reach again to terminal B. So this is a 6 ohms resistor, this is a 24 ohms resistor. Okay. Next, in between again same A and B, I have again 3 ohms and 12 ohms resistors. Clear, ma? So another 2 resistors are, one is 3 ohms, another one is 12 ohms. So 3 ohms and 12 ohms resistors. Okay. Next, if I see these 2 points, they are interconnected. It means these 2 points are connected like this. Okay, ma? Then from the same connection, I have one 8 ohms resistor, which is again reaching to terminal B. So from the same circuit, from the same point, I have one more resistor, 8 ohms resistor, reaching up to point B. So this is the given equivalent circuit. Now it is very easy to simplify, no, ma? Now can you say how can I simplify this one? Now how can I simplify this one, ma? Very simple. 24, 12 and 8. They are connected in parallel connection, no, ma? Next 6 and 3. They are connected in parallel connection. So this total combination and this total combination, they are present in series connection. To this total combination, 12, 12, 12 and 12, they are connected in parallel connection. So just to simplify this one, that should be my required answer. Okay, ma? Come on. So if I take the LCM of these 3, so 1 by 24 plus 1 by 12, sorry, plus 1 by 8. Okay, ma? So LCM of all these 3 is 24 itself. So 1 plus 2 plus 3. So therefore our equivalent of this resistance will be equal to 24 divided by 6. So 4 ohms. So resistance of this total combination is 4 ohms. Next 6 and 3, they are connected in parallel combination. So therefore 6 into 3 divided by 6 plus 3. Okay, ma? So 6 into 3 divided by 9. So 2 ohms. Okay. So this is 2 ohms and this one is 4 ohms. So total resistance of this one is how much? 2 plus 4, it will be equal to 6 ohms. Now 6, this 4 resistors of 12 ohms, they are connected in parallel combination. Clear, ma? So 1, 2, 3, 4. 4 12 ohms resistors. So total equivalent resistance up to these values will be equal to 12 by 4, which is equal to 3 ohms. Clear, ma? So therefore, for all these 12 ohms resistors, I can write equivalent resistance is 12 divided by 4. And equivalent resistance of this branch is equal to 12 plus 4. Okay, ma? Sorry, 2 plus 4. So this is 2, this is 4. So this is terminal A and this is terminal B. Okay, ma? So therefore, 12 plus 12 by 4 is how much? 3. So 3 ohms resistor and 6 ohms resistors, they are again connected in parallel combination. So equivalence of 6 and 3 is how much? 2. So therefore total equivalent resistance between A and B, it is equal to 2 ohms. That's all. Clear, ma? So that is the total equivalent resistance of this circuit. So have you understood, all of you? So just by taking equipotential points, I have redrawn this circuit. That's all. Okay, ma? Then I see that 24, 12 and 8 they are connected in parallel combination. 6 and 3 are also in parallel combination. Next this one and this one they are connected in series. So 4 12 ohms resistors they are connected in parallel. So equivalent resistance of 12 ohms resistors is how much? 12 by 4. That's all, Rama. Next 2 and 4 they are connected in series. That is how we have done this calculation. That's all.